Hello everyone, good evening. I hope you are doing all good. So yeah, welcome back to one more 360DigiTMG's domain analytics session. In the very first session, we have discussed what are the applications of machine learning when it comes to healthcare analytics. And the next day, we have discussed what are the phases when it comes to data science project. We'll be having 6 phases. How we're going to implement those phases we have discussed on the very first day, very second day, and then we have gone through few pre-processing techniques when it comes to text. When you have a text input corpus, you can say, and if you have data set, in that case, how we're going to do some pre-processing techniques. So we have gone through that, and the very next day we have gone through what is a hierarchical clustering, and we have gone through the prime data science prime as well. What are the supervised learning, what are the unsupervised learning, and why we are calling supervised and why we are calling unsupervised, and that we have gone through. And the next day we have gone through the hierarchical clustering. The previous class I'm talking about, we have gone through what are the hierarchical clustering, what are non-hierarchical clustering, and have taken one use case and are we going to apply our hierarchical clustering. Yeah, we have taken the classification algorithm, that is k-means. We have taken k-means algorithm, and one of the use case, that is diabetes. We have taken diabetes data set and we have implemented the k-means algorithm on that and predicted the clusters of patients. And we have generalized those patients, and we have seen that. And in today's session, we'll be discussing about the KNN algorithm, K nearest neighbor algorithm, that is KNN. Using that, we will be doing the classification. We'll be having one use case scenario, and the end of the session, we'll be discussing about the use case scenario. Yeah, before get into the session, yeah, so we have a domain analytics program is going on. If you want to join the Python sessions, and the very from July 11th, we'll be having Python session, basic Python session, that is conducted by Bharani sir himself, in between 6:30 to 7:30. If you want to start your data science journey, please join, or you can subscribe the YouTube channel. So yeah, today we will be discussing about the KNN, K nearest neighbor, and this is we have different names for KNN, that is lazy learning, instance based learning, instant based learning, and memory based learning. Why we are calling this as a lazy learner or instant based learner or memory based learner, we will be seeing in next slide. So why we are naming KNN, that you will come to know eventually right after the session. So first we will be seeing nearest neighbor, how we will be going to implement nearest neighbor, how we going to train our data, machine learning model, that is algorithm nearest neighbor itself, how we going to apply the data sets, training data set, and how we going to train all those things. We'll take the very first, we'll take just one neighbor, and then we'll see how the KNN will be performing, and then we'll take different neighbors. K value will keep increasing the K value, and we'll see and how is going to how the classification will be happening, and then we'll see how we're going to control the complexity of KNN using the K value, and we'll be seeing how we're going to find out the distance, how we're going to calculate the distance between the 2 points. See, most the KNN name itself saying K nearest neighbor. nearest neighbor. So we'll be finding out nearest neighbor, and then we'll be classifying that data set according to previous class. We'll see how it is. Let's say these are the instances we'll be having, or classes we have. Here we have 10 classes. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10. These are the 10 classes we'll be having. So when you want to introduce some number, let's say you have introduced the number 4. Then what k nearest neighbor algorithm do? It will look into the data frame. It will find out the difference, which is similar to this data set, and then it will fit into that class. We'll see how it is doing internally. So k nearest neighbor is an algorithm that we can use for both KNN. We can both use for classification as well as regression. We can use k nearest neighbor, that is KNN algorithm, for both classification and regression. Of course, it is supervised learning. Supervised learning. We should be having the labeled data in our data frame. Then only we can apply the KNN algorithm on that particular data set. So how actually it is, classifying the, how it is classifying the whatever the data set we are giving, how it is classifying, we'll see now. So whenever you mention k is equal to 1, the working of KNN will be saying, now we are saying, whenever you mention k is equal to 1, it will randomly form one data, and then it will calculate just one data point distance. It will calculate the just one data point distance. How it is calculating the data distance? So here we will be using the Euclidean distance. Here we are using the Euclidean distance. What is the Euclidean distance? It is pretty much, let's say you have XY plane and you have two data sets. What is the distance between these two data sets? That is x2 minus x1 whole square plus y2 minus y1 whole square. The same thing we'll be using in the Euclidean distance. That is Euclidean distance when it comes to our data set. So first, whenever you k value is equal to 1, it will simply take one data set nearby and it will calculate the distance, whichever the class that belongs to. Whatever the data set we have introduced, the new data point that we have introduced, it will convert itself into that class. It will convert itself into that class. It is when you have k value is equal to 1. When k value is equal to, when we have a k value is equal to 2, so it will calculate the distance same just like that previously what we did. It is a data point that we have introduced, so it will calculate the distance between both, whichever it is near. Whichever it is near, it will simply convert into that class. Whichever it is near, it will simply convert into that class. Same way, whenever we are having the k value is equal to 3. When you have a k value is equal to 3, in that case, what happens? It will calculate the distance between, it is a random data set that we have introduced, and it will find distance between all three nearby, whichever the nearest. It will calculate the distance between all three, and it will check. Let's say it is data point 1. It is the introduced data. It is whatever the data set we have introduced. And this is data point 2 and data point 3. Whenever k value is equal to 3, what it does, it will calculate distance. Yeah. It will check which class it belongs to, and it will check which class it belongs to, and it will check which class this data point belongs to. Majority, whichever having the majority, whatever the data set, data point that we have introduced, it will convert into majority data set. Whichever is the majority will be having, it will convert into that data set. Here you can see. So this is the this is the data frame that we have introduced, and when k is equal to 3, it is looking at, it is considering only 3 data points around it, whichever the shortest distance it has. So then it will check which class it belongs to, So here we have 2 blue classes, 1 pink classes. In that case, what happens? It will also convert into blue class. Whichever, and when we have k is equal to 3, whichever the highest majority class, you can say, majority class, whichever we have a majority class, it will simply convert into that class. It is when you have k is equal to, same way, any number of k values, k is equal to 8. In that case, what you do, whenever you are introducing the new data point, it will consider shortest distance, 8 shortest distance data points, 8 nearest data points. It will check which are the highest or majority classes it is having. Which are the majority classes will be having. So it will check which is the majority will be having here. So here we have pink. Pink is the majority. In that case, what happens? It will convert itself into pink class. So this is what it keeps happening when it comes to k nearest neighbor. So what happens? Sometimes we might face difficulty, something like blue class is also 4 and pink class is also 4. When we have mentioned k is equal to 8. So in this case, it might face a dilemma. So in that case, what happens? We have to give, we better give k value is equal to odd values. Whenever we give odd values into our model, in that case, what happens? It won't face any dilemma, something like that. Anyway, when k is equal to 3, we won't be facing any dilemma, right? So there will be one majority always. So it will convert itself into that class. So whenever you are applying the k nearest neighbor, try to give k value is equal to r. So this is the working of k nearest neighbor. What it will do? It will calculate the distance, which is the shortest. It will calculate the distance of all. First, it will calculate the distance of all. When we give k is equal to 8, it will calculate the distance between all, but it will keep only 8 shortest distance. It will keep. How it is calculated distance? Say, let's say it is a 2,3, and whatever the data set we have introduced is equal to 2,5. It will calculate distance between both, but that is Euclidean distance. X2 minus x1 whole square, y2 minus y. It will calculate distance, whichever the shortest path, distance we will have. those 8 data points it will take. When you mention k is equal to 8, when you mention k is equal to 3, whichever having the shortest distance among that three shortest distance it will take, and then it will classify. So this is how k nearest neighbor working principle. So when it comes to k value, how do we know that this value will be the perfect? How do we decide? So in that case, we will be doing one graph. Let's say it is x-axis and it is y-axis. It is x-axis and it is y-axis. So here we'll be having k values. K 3, 5, 7, 9, 10, sorry, 9, 11, 13. Better you guys give k value is equal to odd number, then only we can easily, the algorithm won't face any dilemma. So better we should give odd numbers. So whenever we are giving the odd numbers, then we'll be seeing what will be the training set accuracy and the validation set accuracy. So whenever it reaches maximum, and then validation at one point, not a maximum actually, at one point validation set accuracy reach maximum, then it is start dropping. At one point validation set accuracy reaches maximum and then start decreasing. But when it comes to training accuracy, it will keep increasing. The more number of data, the more accuracy will be getting. So the training, it will keep increasing. So you have to find out this point. It is the right level model complexity, or you can say best fit. K is the best value or best fit. Based on this graph only, you will be able to decide which is the best fit. You have to do iteration multiple times, or you can simply use for loop, and we will be doing how we're gonna do multiple iteration using k using the for loop. We'll be seeing that in coding, but you have to do multiple iteration in order to get the maximum accuracy. If once it is reached, you can take this value as a best fit k value. If it is if it is crossing that particular value, it will become overfitting. The model become overfitting model. What is overfitting? Training accuracy is high, but validation accuracy is low. When training accuracy is high and validation, or you can say is testing accuracy. Training accuracy high and validation accuracy is low. In that case, what we thought? It is a overfitting. Overfitting. Or you can say variance. Variance or overfitting. When training accuracy, here you can see, when training accuracy and testing accuracy both are low, in that case, but it is called underfitting. When training accuracy and testing accuracy both are low, in that case it is called as underfitting. What we can do when you have underfitting issues, when training accuracy is low means, but whichever the data that you are giving into your model, whichever the data you are giving into the model, it is not useful to predict that particular prediction, whatever prediction you are doing. It is not sufficient. Maybe you are not giving the best features. So you have to go back to your data, you have to analyze the data, and then you have to come up with some, you have to do some feature engineering, or you need to do some, you need to add the data into your data frame. So you can improve the accuracy of the model. But whenever you are having the overfitting, then you will be having, regularization techniques. Regularization you can do, regularization. In regularization, we'll be having different hyperparameter. hyperparameters. You can tune hyperparameters and you can come up with, or you can increase the accuracy of your model. This is how you can select k value, which is the best fit that you can do using the iteration. It will be possible using the multiple iterations of k value. You have to keep increasing the k values, then only you will be able to see what will be the maximum accuracy for your model. So this is how you will be selecting the k value for your KNN algorithm. Let's take an example and we'll see how we're gonna perform the K algorithm, KNN algorithm. Let's say these are the this is one data set. For example, this is a used toy data set. You can say toy data set. This is a toy data set. In this, what we have, these are the X1, X2. These are the features. X1, X2, X3. These are the features of our data set, and this is output. That is a label. Output, that is a label. How many classes we have? What are the classes? That how many unique values you have in your output column? That is called as a class. So how many classes you have? Fruit, protein, same, vegetable. So here we have 3 classes. So here we have 3 classes. When we introduce something new into a data set, we have, in that case, what you will be giving? You will be giving name. Let's say tomato. We will be doing tomato. Tomato. I am giving tomato. For that, some values I am giving 6 or 4, something like that. These are the sweetness of the tomato and crunchiness of the tomato. Based on these, we have to decide which class it belongs to. Based on these, we have to decide which class it belongs to. How are we going to find out that? Using what? Euclidean distance. Like we have discussed, using Euclidean distance, you can do it. First, what we'll do? We'll be finding out distance between this, using these values only. We'll be finding distance between tomato, right? We have to find out distance between all. We have to find out the distance between all. And then we have to check which is the nearest one. Which is nearest using the Euclidean distance. Same, we have to find out x2 minus x1 whole square, y2 minus y1 whole square. Using the formula, we have to substitute and we have to check this. This you can say x1, x2. Here you can say y1, y2. Find out the distance of all. Distance between this point, distance point. All points. And then you will be getting some values, whichever the shortest. Then you can categorize that into this category, same category. We'll see. I think I have created one data set using that. Here you can see. Here I am introducing the tomato. Get back to that. We'll see how it works in a minute. But before that, yeah. So what happens whenever the data frame is given? This is how different. We'll be having different all those fruits. These are the different data points we'll be having based on our data frame. Based on data frame, this is how we'll be getting when it comes to XY plane. And here what we are doing, we have to introduce something based on their features. These are categorized into different vegetable, proteins, and fruits. Based on their features, which are features present in our data set. Those features only will be categorized into different categories. Then what we are doing? We are introducing one new element. Then we are introducing one new element. It is not right here, but we are saying this is one new data point I'm introducing. Now I want to check which category it belongs to, whether it is belong to vegetable, protein, fruit. We have to check based on what we'll be having features, right? Every data point has features. The data frame we have seen right previously, crunchiness and sweetness. Based on those, these categories or these classes has been formed. So now we have introduced one data point, that is tomato. We have features for that too, and based on those features, we have to decide which class it belongs to. So what are the features of the tomato? Yeah, here it is given tomato features. Sweetness is 6, crunchiness is 4. These are the features of tomato. Yeah. So randomly, one data frame is introduced into the previous, or you can say right after building the data or machine learning model, we have given new features. Now it has to select or we have to predict which category that particular data point that we have introduced, that is tomato that we have introduced. It has to find out which category or which class it belongs to. So how we want to calculate? We'll see. Here the same data set that we have taken, that is apple. Let's say it is pineapple, anything. Banana, carrot, celery, and cheese. These are the data set we have, and in that, these are the data points. These are the data points. So we have features for each and every entry. 10, sweetness is 10, crunchiness is 9. Sweetness is 1 and crunchiness is 4. Sweetness is 10, crunchiness is sweetness. These are all features. Based on these features, these are categorized into fruit, vegetable, fruit, vegetable, vegetable, vegetable. Apple comes under fruit. It is pineapple cell. This is comes under, based on, don't take literally, but this is the toy data set. So now we have introduced one tomato. 6, 4. We have introduced 6 and 4. Now what we have to do? We have to calculate distance between all. Now we have to calculate distance between all. When k is equal to 1. When k is equal to 1. What happened when k is equal to 1? Whichever the shortest distance, tomato, whichever the shortest distance. So these are the distance between, whenever we are using the Euclidean distance, that is x2 minus x1 whole square plus y2 minus y1 whole square. Whenever we are calculating the Euclidean distance, these are the data, the distance we have found. Which is the shortest one here? It is a 1.4. So based on that, if you have just given k is equal to 1, in that case, you can simply say that tomato belongs to vegetable category. Whichever the k value 1, whenever we are taking k value is equal to 1, you can simply say whichever the shortest distance we will be having, that is belongs to our tomato. Whichever the new point that we have introduced, that belongs to the vegetable category. Shortest distance belongs to vegetable category, so it belongs to the vegetable class or category. What happens when k is equal to 3? Whenever k value is equal to 3, the same, we have already calculated distance. Then we will look into the 3 shortest distance. 3 shortest distances. So what are the 3 shortest distance we'll be having? So these are the shortest distance compared to others. So in that three shortest distance, which is the majority class will be having. Here it is fruit, it is vegetable and vegetable. So we have a majority class is equal to vegetable. So whichever the data point that we have introduced, it becomes that class. So here the tomato becomes a vegetable class. So this is how we will be in KNN algorithm, K nearest neighbor. That is why it is called as a K nearest neighbor. We'll be calculating the nearest neighbor. If it is K is equal to 1, the same K nearest neighbor will be classified into the same nearest neighbor, whichever the class that belongs to. The given point or the whichever data point that you have introduced, that becomes that class, belongs to that class. Whenever K is equal to 3, we'll be calculating the shortest distance, 3 shortest distances. Whichever is the majority class will be having, that becomes the introduced data point class. I hope you guys understood. Yeah. So this is how it is deciding the which class that particular category belongs to. So we have just given how we are going to calculate the similarity, how we're going to find out algorithm using the Euclidean. So this is the Euclidean distance and this formula. So now we'll see how we will be implementing the same K nearest neighbor when it comes to use case scenario. So here we'll be taking one data set, that is a breast cancer data set. In that we'll be having different features. We'll go through those features. Based on those features or input columns, you can say features or input columns. Based on those input features, we have to predict. We have to predict whether that particular person or a patient belong to benign, the cancer is benign or malignant. We have to decide whether it is benign or malignant. We'll see the data. Yeah, here, whenever you want to work on this is a notebook we are using, notebook. You can use Spider as well. You can use Spider as well. So why we are using why we are using the pandas and why we are using NumPy means. So in order to import the data set, or in order to do manipulations in the data. In order to do manipulation in the data, we will be using the pandas. We'll be using the first, so we have to import pandas in order to do manipulation of data. Manipulation means you can change changes, whatever changes we want to change column name, or you want to change missing values. You want to impute the missing values. All those things operation will be done using the pandas. So we have to import the pandas, and when it comes to NumPy, whichever the mathematical calculation we are doing, it is all handled by the library called NumPy. Whichever the mathematical calculation we are doing, this will be done by NumPy library. So here we are importing the import pandas as PD. Same pandas I'm importing a short form PD, so that we can use just PD form instead of writing pandas. And I'm importing the NumPy as NP. I'm importing the NumPy from I'm importing the NumPy as a NP. Once it is done, It is a Kaggle data, guys. I've taken this data from Kaggle. If you want to work on it, you can simply type WBCD. WBCD. It is a breast cancer Wisconsin data set. Wisconsin breast cancer data set. If you want to work on it, you can go. Let me run it. Yeah. And I'm importing the data set using the pandas.read_cv. In order to read the data also you need pandas library. Yeah. So this is the description of our data set features. Whichever the feature we are using, this is the description of those features. You can go through it. Real valued features are computed for cell number. So radius, we have texture, standard deviation, and grayscale values. Perimeter and area, smoothness, local variation, radius length, compactness. These are the measurements of that particular diagnosis. Or you can say the area of that particular. These are the measurements we'll be having when it comes to data set. Just use head. What happens when you use head? By default, top 5. Whichever the 5 entries. First 5 entries, not top 5. First 5 entries will be displayed. These are the first 5 entries. Here, of course, we are working on supervised class. Supervised class. In that case, what happens? Whenever you are working on supervised, you need to have output or label. You need to have a label data, a label column, a label feature, you can say. So here we'll be having diagnosis as a label. And these are all rest features, input features. These will be helping us to decide whether diagnosis, whether it is banana, malignant. So this is the data set. Whenever you use head, first 5 data entries will be displayed. First 5 data entries will be displayed. We have 32 features. We have 32 features. Among ID is 1. So I'm just converting those B into banana and malignant so that you can easily understand. I mean, I'm working on data. I might be having idea about that, but people who are reading it, they might not have an idea. So I'm just converting that B into banana and M into malignant. Yeah. So here what I'm doing, ID. We don't really need this ID because we won't be able to infer anything from this data. So it is not useful for us to predict the output or predict the diagnosis, whether it is banana or malignant. You won't be able to infer anything from this ID data. So it is just nominal data. I can say it is nominal data. You won't be able to infer anything. In that case, you can simply drop that column. It is not necessary for our data set. So I'm simply dropping that column. We want to see what is the data frame right after that. So we have eliminated that the very first column, and then we have changed. So we have simply eliminated the first one, and it is the input data because we'll be taking that diagnosis column into output, or you can say the target column. It is a target column, and the rest are input column. So I'm just taking the only input and I have removed that ID column. Since there is so much variation in our data, you can see some columns we have just 0.08 and some column we have thousands, 500, 400, something like that. Some we have 100. So there is so much variation in between the, or you can say different scales. Each column has a different scale. In order to avoid that, you have to bring all those input columns into single scale, or you can say scale free. Scale free. To bring all those input feature into single unit or single unit scale. In that case, we will be doing the normalization. What does normalization do? It will simply bring all the features in between, feature values in between 0 and 1. It will bring all the features values in between 0 and 1. So we don't face that variation in between input column. What happens when you have variation? Let's say you are predicting the diagnosis. You are predicting the diagnosis. Here you have just 0.1 and here are 0. Yeah, it is fine. But when it comes to here, so it might affect, right? So it will be, whenever you are predicting something, it will be having a high effect on that prediction rather compared to this. So it will be having higher importance. So there might be a bias. So in order to avoid that, we are simply doing the normalization. And then we are fitting into the data. And now we are deciding which is the target and which are the prediction. We have normalized data. Yeah, the same program run. I think I haven't downloaded that. Okay. So what we are doing, first we are doing the normalization and then we are converting into normalization. Then we are dividing into predictor, and this is the predictor and we are target. Then we are doing the splitting. Whichever the data will be having, we are splitting into train and test. We are splitting into train and test. You can simply see whichever the text you can look at the test data. Right after normalization, you can see all those values in between 0 and 1. All those values in between 0 and 1. That is the test data, and you can check the train data as well. So overall, how many entries we have? This is the train data. Everything in between 0 and 1. Since we are doing the normalization. So how many entries we had previously? All 569. In that, train data will be 455 and the test data will be 114, because we are splitting 0.2. So here test data will be 20% and train data will be 80%. Overall, in 569, 80% data will be given to train and 20% data will be given to test. And whenever you are working on classification, you have to look at classification, you have to look at whether whichever the class you are considering, is it balanced or not. You have to check it. Whenever you are working on the classification, you have to check the classes whether it is balanced or not. So we'll check that first. If it is not balanced, in that case, you have to do balance. We'll be having different techniques. So when we will be calling the balanced data and when we will be calling the unbalanced data, it is one thumb rule you have to remember, guys. At least any one of the class. Let's say we are going for benign and malignant, right? Any one of the class should have 30% of data when it comes to test or train. At least one of the class should be less than just at least 30. At least 30 it should have. If it is less than 30, any of this less than 30, in that case, it is considered as an unbalanced data. You should have at least 30 minimum. If it is less than 30, let's say benign, malignant. Overall data it is 100. Data means the entries you can say. Here we have 70 and here are 30. In that case, it is called as a balanced data. But it is 71 and it is 29. In that case, it is called as an unbalanced data. Here you have 71 and here 29. Then also it is called as an unbalanced data. So you should keep that in mind whenever you are working on the classification algorithm. You should have at least one as a 30. One class as a 30, then only it will be considered as a balanced data set. Here, how many have? Benign cases 357 and 212. So we have sufficient. We have something like 60 to 40. So you can consider this as a classification or balanced data. It will be considered as a balanced data. Yeah, once it is done, we are training. We are checking it, train data and test data in train. So we have it is also balanced data. So no problem. We can simply import the algorithm neighbor that algorithm we have to import. Here I am using k value is equal to 21. Here I am randomly I am using k is equal to 21. You can use anything. Anyway, we'll be using that for loop in order to find out which value will be the best. But I'm using the k is equal to 21. You can use any value, no problem. So I'm fitting the train data and test data in our algorithm. Done. Now I'm predicting on test data. Predict. So these are the all prediction we are getting. These are all prediction we are getting. Once the prediction is done, we have to see or you have to evaluate model. What is evaluation of model? Just checking actual value and predicted value. What are the actual value we have and how many predicted values we'll have, and then we'll compare both. Here what in prediction it is done. It is the actual value and it is the prediction. Benign and benign both are same. I mean number of benign cases and actual the predictions. So these are the predictions and these are actual value. So it is a benign and it is benign. Both are benign. Means it is classified correctly. It is 67 cases. It is classified correctly. And benign cases, malignant cases, this is also malignant and this is also malignant. In that case, it is also predicted correctly. And here we have 0. These are misclassified cases. Here we have 0 misclassified cases when it comes to benign and malignant, and here we have 4 misclassified cases. So can we say it is a good algorithm or good accuracy will be having? Yeah, I can say, because you will be having minimal misclassified cases. Then we'll be checking the accuracy in our data. We'll be checking the accuracy. We are calculating the same in test data, train data. Previously we have did for test data. Now we are checking for train data. So here 288 classified correctly. Here 149 classified correctly, and here 2 misclassified, and here 16 misclassified cases here. This is confusion matrix, you can say, or you can is called as a cross table. It will tell you how many misclassified cases you have, how many correctly classified cases you have. So this is how you will be training your model. So finally, what I'm doing, I'm just checking which at which k value I'll be getting the maximum accuracy I'll be getting. So for that, I'm just using one for loop, and that I'm taking the k values from 1 to 50. Here it is a starting point, it is a stopping point, and it is step. I'm taking 1 to 50. Those are all odd numbers because I'm using a step. 1, 3, 5, 7, 9, 11, something like that. Up to 50 I'm taking. Up to 50 I'm taking. Right? And then I'm using the one plot in order to see which is my best. So here we'll be having the k values, different k values, and their test accuracy and train accuracy. Test accuracy and train accuracy. See, it is keep decreasing, and here it is increased and then keep decreasing. So you can say here it is a perfect k point value. Here you can say k is a perfect value, or you can say best fit value here. Whenever you use value in between something like 7 or 8, you can check 6 also. 6, 7, 8, 9. Instead of going for this many iteration, why can't we check just 4, 7, 8, 9, 10? Check all k values and check accuracy of that particular model, and you will be getting whichever the best accuracy you have. Just take that k value as the best fit. So yeah, this is how we'll be calculating the whether that particular case is benign or malignant, and how we gonna calculate, or how we gonna check which is the best k value for our model. So this is the one of the use case scenario, guys, when it comes to using the KNN algorithm. KNN algorithm. So I have tried to show you guys using running that program so that you can understand what exactly going on. How will be predicting whether that particular case is benign or malignant. Benign or malignant using the data frame. So yeah, this is all about KNN and the one use case that we have seen, that is predicting the banana malignant. So yeah, that is it for today, guys. If you have liked the video, or if you want to watch these kind of content or use cases, in the next class we'll be coming up with simple linear regression with one use case. We'll be coming in next class with simple linear regression, and we're going to apply the same simple linear regression, that is machine learning model. In healthcare analytics, we'll be using one use case, and we'll try to apply that machine learning algorithm in healthcare analytics. And if you want to start your career in data science from 11th July, there will be basic Python classes will be started by Bharani sir. So if you want to start your data science career in data science, you can join, guys. And yeah, that's it for today, guys. And I hope you learned something, and we'll see you in the next class. And